Yeah, good morning all. Now I am going to discuss some more problems on power systems. Okay, already 15 questions are completed, right? Next 16th one. For protection of parallel feeders fed from one end, the relays required are okay. That means if bus is connected means it is having source as well as load. Okay, remember one point, always source side. Okay, source side directional relay is not required. Hence, source side is non-directional relay and the load side is directional relay is required for the protection of parallel feeders. Okay, fed from one end. Okay, now see here, first option is non-directional relay at the source side and directional relay at the load side. That is first option is correct, right? Now see the answers. 16th one, here it is B. Oh yes, wait a minute. No, 16th one is a first option A is correct. That is non-directional relay at the source end and directional relay at the load end. Okay, you can correct it. 16th one answer is A. Next, 17th one. The number of pilot wires required for protecting three-phase transmission line by using translay system protection. Okay, the major advantage of translay protection system is number of pilot wires required is less, right? For a three-phase system, it requires only two pilot wires. So for example, if it is a differential protection, for differential protection, it requires 6 pilot wires. That means number of phases into 2. Okay, for single phase only 2 pilot wires. But whereas in case of three-phase transmission line, in case of three-phase transmission line, by using transit system, it requires only 2 pilot wires. Okay, that means the answer is correct. Next, 18th one. A shunt fault is characterized by option A, increase in current, frequency and power factor. That means increase in current, frequency, power factor. Option B, increase in current and reduction in frequency and power factor. Option C, increase in current and frequency but reduction in power factor. Option D, none of the above. Shunt fault is nothing but a short circuit fault. Under short circuit condition, increase in current, right? First is correct. That means first three options is correct. That means first point in three options. Next, in case of shunt fault, power factor and frequency should be reduced. See here, for a shunt fault, current is increases, frequency and power factor is reduces. For a series fault, series is nothing but open circuit fault. For open circuit fault, supply voltage increases, current is reduces, frequency is also increases. That means here is given shunt fault, right? That means current is increases and power factor and frequency should be reduced. That means second answer is correct. Next, for measuring positive, negative and zero sequence voltages in a system, the reference is taken as, okay, for the measurement of positive, zero and negative sequence quantities, for positive sequence and negative sequence quantities, reference is taken as neutral. Okay, for zero sequence, reference is taken as ground. See here, for positive and negative sequence, reference is taken as neutral. For zero sequence, reference is taken as ground. Now see the options. Neutral of the system, only neutral, that is not correct. Only ground, B is also not correct. For zero sequence, neutral, that is also not correct, right? For zero sequence, ground is required, and for positive and negative, neutral is required. C is also not correct. That means fourth option is correct. Okay, the most economical load on an overhead line is, okay, in case of overhead lines, the most economical load is always greater than surge impedance load or natural impedance load. That load is equals to V square by ZC. Now see here, first option greater than the natural load or surge impedance load. That means first option is correct. Next, 21st question. The most economical load on an underground cable. In case of underground cables, economical load is always less than the surge impedance loading. Okay, that is less than the surge impedance loading. That is second one, right? 21st answer is B. Okay, next 22nd one. For a long transmission line, for a particular receiving end voltage, when sending end voltage is calculated, okay, it is more than the actual value when calculated. Okay, that means what is given for a long transmission line for a particular receiving end voltage, when sending end voltage is calculated, that is more than receiving end voltage. Okay, when sending end voltage